Bright QT. Every student matters.
Hello students, let's continue with comparing quantities. So as I told you, in this video we're going to work on compound interest. So let's start with it. What do we mean by compound interest? We will learn it slowly with different examples. So suppose you might come across the statements like on FD, okay, interest is there, okay, on FD there is an interest and it is at the rate 9% per year, or we say per annum, right? Or you say a savings account, that is in bank, savings account in a bank, okay, at the rate of 5% per annum with interest, okay. So what do we mean when we hear about these statements, or when we understand these statements? That means on the fixed deposit or on the savings account there is interest that is added every year to the amount that is there in the account. So actually interest is what? Okay, so interest is paid by the institutions like bank, like post offices, to the government, okay, for keeping the money with them. Also it is paid by the people, okay, also it is paid by the bank, or it is paid by the people also, okay. So that is known as compound interest. Now we are aware of simple interest that is calculated every year and it remains same. But in case of compound interest, there comes a little difference that we are going to notice now. So here is one question that I would like you to attempt for simple interest, so that we recall the concept of simple interest, and then we will move to compound interest. Okay, so it is saying a sum of rupees 10,000 is borrowed at the rate of 15% per annum for 2 years. Okay, what is the sum given? 10,000. So principal is equal to 10,000. I'll write rupees. It is rupees 10,000. Interest is, we denote it with capital I, 15%, okay, per annum for 2 years. How much time is given? 2 years. Okay, we have to find the simple interest on this sum. So you all know the formula of simple interest: principal into rate into time divided by 100. Principal is 10,000 into 15 into 2 divide by 100, cancelling the zeros. So what we will get? 15 to the 30, and here also 100. So we get rupees 3,000. This is the simple interest after 2 years. At the end of 1 year it will be 1500. Okay, if you put the time as 1, it will be 1500, and then you can multiply it for 2. We have calculated for 2 years collectively. Then we have to tell the amount to be paid at the end of 2 years. You know the formula of amount. You already are familiar with all these things. So simple interest plus principal. Okay, in the amount that was borrowed, that is 10,000 principal, we add the interest, that is rupees 3,000. So how much money? 10,000 plus 3,000, 13,000. Getting it? 10,000 was the initial amount and he borrowed at the rate of 15% per annum. So by this rate, or we should write it at R, right? So R is the rate of interest and it is given as 15%. So rate is given, time is given 2 years. We calculated simple interest, that is 3,000. So in principle we will add this interest, we get the amount to be paid at the end of 2 years. Clear? This is what we were doing in simple interest, right? Let's move to compound interest now. So here is one more question. Okay, before that, so here also you have to calculate the interest and amount to be paid for rupees 15,000. So this will become your principal, this is your rate, and this is your time. So how do you calculate the simple interest? P into R into T, that is principal into rate into time divided by 100. Principal is 15,000 into rate is 5 into time is 2 divided by 100. So just to see, 5 to the 10, 150 into 10 is rupees 1500, right? For 2 years this is the amount that is added in the principal. So amount to be paid at the end. The person has to pay definitely the money, that is rupees 15,000, plus the interest that is made on it, 1500. So 15,000, you add 1500, how much you are going to get? 16,500. This is the amount he has to pay at the end. Clear? Okay. So here is something written, read it carefully. The interest is calculated on the amount of previous years. This is known as interest compounded or compound interest. What do we mean by this statement? See, I say that I have some money in bank and the interest added on it every year, it is different. It is not same. Right? Why it is not same? Because it is calculated on the amount of the previous year. Read this, on the amount of previous year. Here, in case of simple interest, we were calculating it using how? We were calculating it for collective 2 years, and for each year it will be same. It will be on the same amount, 15,000. Right? For 15,000 you calculate for 1 year, it will be 750, and for another year it will be 750. In all total you will get 1500. But here in this case, it is on the amount of the previous year. This means that, see, this suppose some principal I have, let us name it as P1. Okay, or let's do some example to understand it, that will be more clearly understood. So how do we calculate compound interest? We'll take one example for it. Okay, so here is an example written. The principal is 20,000 and it is borrowed by Hina for 2 years. Right, a sum of rupees 20,000, that means this is the principal, is borrowed by Hina for 2 years at an interest of 8% compounded annually. Read this word carefully. Compounded annually means in the second year, when we find out the interest, it is going to be on the amount, not on the principal. Clear? Find the compound interest and the amount she has to pay at the end of 2 years. So we have to find compound interest and the amount she has to pay at the end of 2 years. So in compound interest, we don't calculate it collectively, we will calculate year by year. Fine, because at the end there is a little change as compared to simple interest. In simple interest, whatever principal is there, that will remain throughout, right, for all the years. But in compound interest, the next principal, the principal for the second year, is the amount of the previous year. How? See, what is the principal here? 20,000. We will write it is 20,000. Okay, let's write it as P1, that is for the first year. Time for 2 years and at an interest of 8% compounded annually. Annually means per year. We will not calculate it collectively for 2 years. We'll calculate it annually first. That means for 1 year. Okay, so if I take T1, that is the time, that will be 1 year. Okay, and what is the rate of interest? It is 8%. Okay, so let's calculate the interest first. Okay, so interest I1, I am naming it. So it is going to be simple, right, as in the first case. So principal into rate into time divided by 100. So cancel it. You get how much? 8 to the 16, 1600. This is the interest that is to be paid. So what is the amount for first year? It is principal for first year and interest for first year. Principal for first year is rupees 20,000 and interest for first year is rupees 1600. So we get 21,600. This is the amount that will be paid at the end of first year. Now the things come for second year. Now this amount 1, right, this will become principal for second year. P2 means principal for second year. A1 means amount for the first one. Right, now this will become our principal. So principal is rupees 21,600. Rate is same because for 2 years it is same. Time again we will take, it is the next year. For the second year we are calculating. So can we calculate the interest? Yes, I2 will be principal into rate into time divided by 100. Right, cancel it. How much do you get? We have to multiply 216 with 8. 8 6 are 48, carries 4. 8 1s are 8 and 4, 12. 1 is a carry. 8 2s are 16 and 1, 17. So 1728 is the interest for second year. What is the amount for second year? Principal for second year, that is rupees 21,600 plus interest for second year, that is rupees 1768. Getting it? So what will be the final amount at the end of 2 years? We have to add 21,600 with 1768. Let's add it here. 21,600 and then we have 1768. 8, 6. 6 and 7, 13. 1 and 1, 2 and 1, 3 and 2. So 23,368. This is the amount that is Hina will pay at the end of 2 years. Clear? If this would have not been compounded annually, this would have been simple interest, right? So as what we have done, we will do the same thing, right? This will be the same thing. Now P2 will also remain 20,000 only. In case of simple interest, we don't change the principal. It remains same for all the years, whatever number of years is given in the question. But in compound interest, the difference, the major difference between simple interest and compound interest is this only, that interest now will be calculated on the amount of the previous year, as you can see. Clear? It will not keep the principal same. It is going to be changed, and that's how we change the amount at the end of 2 years. Clear? So this is how you are going to solve it. I hope this gives you a clear idea of what compound interest is, right? So whenever it is written compounded annually, right? So what is the total interest that the person has paid, right? We have find the compound interest, we have calculated the amount she has to pay at the end of 2 years. Total interest is how much? You have to just add I1, right, and I2. When you add these two, you get the total interest paid. Clear? Let's move ahead now. So the idea of compound interest will be more clear using this table and the values written here. So I'll take one by one each of them. Just see. For the first year, we have taken the principal as rupees 100 in both the case. This is for simple interest, this is for compound interest. Now interest at 10% rate. 10% of 100 will be rupees 10. Right, in both the cases. So amount will be interest plus principal. So in this and this it is same. Now in the next one, principal will remain same, but here principal will not remain same. Principal will become the amount of the previous year, that is 110. That is the major difference you need to notice here. Here the principal is 100, but here the principal is 110. Now 10% of 100 is 10 only, right? So we get 120 rupees here, but because 110 we already had, and 10 more is added as an interest, right? So 120 we have to pay at the second year, end of second year. Here 10% of 110 is 11, so we have to pay 121 rupees. Now in the third year, the interest will remain same, the principal will remain same, so 120 we have to pay at the end of second year, and 10 rupees will be added in the next year. So at the end of third year we have to pay total 130 rupees, but here we have to pay just the 121 will become the principal, and then 10% of 121 is 12. When we added them, we get this amount. So at the end of third year, if that interest is compounded annually, so we have to pay 133.10. So see how much is the difference? 133.10 minus 130. You get it? Just see 133.10 and 130. If we subtract, we get 10,300 rupees 3.10. This is the extra money that is added when the interest is compounded annually. So this is the major difference, and the interest is never simple. In banks it is compounded annually. Every year it is different. It is calculated on the amount of the previous years. Clear? So this is the funda, this is the concept of compound interest mainly. So what we need to keep in mind? We need to keep in mind that when we do it for second year, we have to keep the principal as the amount of previous year. Clear? Now we are going to learn how to deduce a formula for compound interest. Right? So we will take one example and get the formula. Let's do that. Okay. So let us learn how to get the formula. So I'll just take one simple example and then we will write the result in a general form. So let's take the principal is rupees 5,000, okay, and rate is 5% and it is compounded annually. Okay, so with the help of simple interest only, I'll get the formula for compound interest. So let us consider the first year principal is rupees 5,000. Okay, rate will remain same for all the years, 5%. So what will be the interest for first year? Principal into rate into time divided by, because annually, that's why I'm taking 1 as the time period, 100. So divide it, we will get 5 5s are 25, 250. Are you getting it? What we get? Interest is 5,000 into 5, that is rate, into 1 divided by 100. 100 and these 100 will get cancelled. 5 5s are 25, we get 250. This is the interest for the first year. Now what will be the amount for first year? That is principal 5,000 plus 250, right? So we get it as 5,250. Clear? Now we know that this amount will become the principal for second year. 5,250 will become the amount for next year. Clear? Or what we can do is, if you know you want it to be more simpler, what you can do, we can erase it and just keep the answer in this form. Just keep it in this form. Okay, don't cancel the terms. Let it be like this. Okay, so we have got the interest. So what will be the amount for first year? Amount for first year is principal, that is rupees 5,000, plus interest is rupees 5,000 into 5 divided by 100. So what is common out of this? We are taking common 5,000. Here 1 is left, plus 5 upon 100. Okay, this is the amount for first year. Now what will happen? This amount will become principal for the second year. So P2 will be equal to the amount for first year, that is rupees 5,000 into 1 plus 5 upon 100. Rate is 5%. Let's calculate the interest for second year. Interest for second year is principal, that is 5,000 into 1 plus 5 upon 100, right? I'm not solving it, taking the exact values to just get the formula. So interest is this principal into rate into time divided by 100. Clear? This we are going to get. Are you getting it? So what we will get? 5,000 into 5 upon 100 into 1 plus 5 upon 100. Clear? I have just collected these two with 5,000. Now this is the interest. So what will be the amount for second year? Amount for second year is principal for second year, that is this, which is rupees 5,000 into 1 plus 5 by 100, plus this we will write, right? So 5,000 into 5 upon 100 into 1 plus 5 upon 100. So we observe here is in the whole bracket we can take rupees 5,000 into 1 plus 5 by 100. These two terms are here in the first one as well as in the second one. If we take that common, here we are left just with 1 and here with 5 upon 100. So you see 1 plus 5 upon 100 is coming up 2 times, right? So the final amount, the second year amount, can be written as 5,000 into 1 plus 5 upon 100 to the power 2, because it's a square now. Two things are getting multiplied. So what I have done in the last step, I have taken 5,000 into 1 plus 5 upon 100 because it is there in both the terms. It came common and we are left with 1 plus 5 by 100. So what do you observe here? We observe here that when it is for first year, the power is 1. When it is for second year, the power is 2. Okay. What is this in both the case? It is principal. It is also principal. Then 1 is same in both of them. Then it is 5. 5 is what? The rate, 5%. So 5 upon 100. So if I write the formula in a general way, how we can write? We can write it as amount for n years will be calculated as, in case of compound interest, principal into 1 plus r upon 100 to the power n. Clear? N is the number of years. So just see, in the previous case, when we had A1, we had the power as 1. When we had A2, that is the second amount, second year amount, we have the power as 2, and everything else is same. So what is that everything else? That is principal and rate. Clear? So like this we are going to calculate compound interest. So this is the major formula, general formula for calculating compound interest, right? We will use this to find out the questions. So let us practice questions on this formula, try to apply this, and we will see how this formula works in questions. Clear? So what do we need to see? That we have calculated amount. How to calculate compound interest? It is by the formula amount minus principal. Clear? Let's practice one question. Here is one question. It is asking find compound interest. We have to calculate your CI for 12,600. That is the principal, rupees 12,600. Time is for 2 years. That means N is 2 years, right? At 10% rate is 10% per annum compounded annually. So we know how to calculate the amount for 2 years directly, because for each year if we calculate, that takes a lot of time. That's why we deduce this formula. Amount is for n years, it will be calculated as like this. So using the same formula, what is the formula? P into 1 plus R upon 100 to the power n. N here is 2, right? So here A2 means it is the amount for second year. That means at the end of second year, for 2 years we are calculating. So we will write 12,600 into 1 plus rate is 10%. So 10 upon 100, gives us 1 upon 10 to the power 2. Taking the LCM, we get 12,600 into 11 by 10 to the power 2. Solving it, you will get rupees 12,600 into 11 by 10 into 11 by 10. Cancel them, the zeros. You get rupees 126 into 11 is 121. Right? Now we can multiply it to get the amount. Okay, let us multiply 126 with 121. You are going to get 15,246. Clear? So now we have calculated the amount. How to calculate the compound interest? We know compound interest is amount minus principal. So rupees 15,246. From this we will subtract rupees. How much? What is the principal? 12,600. Subtract it. So 15,246 and 12,600. So we get 6. 4. 12 minus 6 is 6. 4 minus 2 is 2. Rupees 2,646. So this is the extra money that will be paid at the end of 2 years if it is compounded annually. This is the interest, right? Compound interest that the person has to pay. 2,646. Clear? So whenever interest is compounded annually, it is more than simple interest always. Clear? So we have now deduced one formula for amount of the number of years, whatever it is given in the question, if they are compounded annually. Clear? Let's do one more question. Here is another question of the same kind. It says again we have to find out compound interest, and the principal is given as rupees 8,000. Rate is given as 5%. Time t, or we say n here, is given as 2 years. So how to calculate the amount? P into 1 plus R by 100 to the power n. So P is 8,000 into 1 plus rate is 5 upon 100 into n is 2 here. So 8,000 into, cancel it, 5 ones are 5 twos are 10, 20, 1 plus 1 upon 20 to the power 2. It will become 8,000, okay, into 1 plus 20. If you take 20 as the LCM, you will get 21 upon 20 to the power 2. So we will solve it. 8,000 into 21 upon 20 into 21 upon 20. Let's cancel it. 21s are 20, 24s are 80, and then we have 2 zeros. Again 21s are 20, 22s are 40 and 0. So 20 into 21 into 21 is 441. Let us multiply. We get the amount as rupees 441 multiply by 2. 2 1 ja 2, 2 4 ja 8, 2 4 ja 8, right? 8,820. This is the amount that is to be paid, right? How to find out compound interest? Compound interest is amount minus principal. So rupees 8,820 minus rupees 8,000. So we will calculate the interest because we are paying more amount. That means interest is added in the amount. So when we solve it, we get 820. So this is the extra money that will be paid. This is the interest that will be there on rupees 8,000. Clear? Okay, so what we have learned in this lecture, we have learned how to find out compound interest, what is the difference between simple interest and compound interest. So in the next one, I'll teach you when interest is compounded half yearly or annually. Like annually we have sold, so half yearly when it is given. So there are some changes in the timings, and then we are going to learn one more concept, that is application of this, right? So we'll have some real life problems, real life situation questions, and we're going to apply the concept of compound interest in that, right? So we are going to learn rate compounded annually or half yearly, or we say semi-annually. It can also be quarterly. Right. So what does we mean? What do we mean, when we say, or whenever it is written in the question that it is compounded half yearly, it is compounded quarterly after 3 months, that means, because we know 3 3 3 3 4 groups can be made of 3 months each, and we complete 1 year, so there are 4 quarters of 3 months each. Now just see this table. Okay, there is a lot to understand from this. We have what? We have principal as rupees 100 at 10% per annum compounded annually, right? For the first year the interest remains the same as it is simple interest. Also we could have used the formula for amount, that is principal into 1 plus rate, that is 10 upon 100 to the power annually, so it will be 1. So 100 into, just cancelling it, 1 upon 10, you take 10 as the LCM, you will get 11 upon 10. Okay, solving it, just see, we are getting rupees 110 as we got here by calculating the interest, simple interest, and we added the interest into the principal, we got 110. So when it is written compounded annually, we can directly use the formula for amount and calculate the amount, that is rupees 110. Now here it is written the same question and it is compounded half yearly. Here half yearly means the principal will remain same for first 6 months, and then the amount for those 6 months will become the principal for next 6 months. Here the principal will change after half year. Half year means 6 months. So here time period is 6 months or half year. When we place the value, just see here what is happening. 10 into half year. So when we place half year, just see, rate becomes 5% instead of 10%. So rate is getting half, right? Again when we got interest, we added it into the principal and we got the amount to be paid for after the 6 months, that is 105. Now after 105, now this 105 will become the principal for the second year. So we are writing 105 as the principal for 6 year, and here again the rate is half. So what we observe is when it is half yearly, the rate will become half and time will become twice. As you see, half yearly, so half year and half year here, it is getting doubled. So we are getting the amount by adding this one. So here it is different. Right, when it is compounded annually, for the complete year it remains 10% and on 100 rupees. So we have to pay at last 110 rupees. But if it compounded half yearly, that means after half year, after 6 months, the amount will, the principal will change. The principal will be the amount for that previous 6 months. Okay, that's why we have to pay here 110.25. 0.25 is the extra money that we have to pay if it is compounded half yearly. Clear? So time is twice, that means here if I had to calculate half yearly, I'll take NS2 in the formula. So just have to take amount. Okay, amount will be calculated as principal that is 100 into 1 plus rate is 10%. So what we need to take? Half of the rate, 5%. And time will be how much years? And will be 2 here, because there are 2 half years. So 2. Now when you solve it, 100 into, just it will be 105 upon 100 and into 105 upon 100. So this will get cancelled out, and rest you can solve and get the answer. You will get the same answer as 110.25. So what I want to teach you from this is that when it is compounded annually, for the complete year the rate remains same, right? And the time is 1 year here. But when it's compounded half yearly, in 1 year there are 2 half years, so we take n as 2. If it is 1.5 year, okay, suppose it is 1.5 year, so how many half years we have? We have 3 half years, so n becomes 3 in this case, okay, and rate will become half because it is compounded half yearly. If rate is given 10%, it will be 5%. If it is 15%, it will be 15% upon 2, that is 7.5%. Clear? So what is the conclusion? The conclusion is here that if interest is compounded half yearly, then we compute interest 2 times, time period is twice, and rate is taken half. So just see here now. There are 2 questions that we will attempt to understand this concept more clearly. In the first question, it is given a sum for 1.5 years. Right? How many half years? 3 half years. Okay. At 8% per annum is compounded half yearly. Half yearly, if it is compounded, rate will become half. So just see, we have to find the time period. So n is equal to 3 and rate is, just see, 4%, half of 8%. In the second question, they are asking a sum is taken for 2 years at 4% per annum, compounded half yearly. In 2 years, how many half years we have? 4 half years we have. 6 months plus 6 months plus 6 months plus 6 months. We have 4 half years, right? So time period is n equal to 4. And what is the rate here? Half yearly, because it is, rate will be 2% instead of 4%. Is that clear? So whenever these kind of statements are given, we take time period and rate as like this. I hope this is clear, and we can now attempt questions based on half yearly, quarterly, like this. So just see here. Here is one question. It is asking a sum is taken for 1 year at 16% per annum if interest is compounded after every 3 months. Okay, after every 3 months, how many times will interest be charged in 1 year? First interest will be after 3 months, because it is compounded, it will change again. Second interest will be after 6 months, that means the 6th month, after the 6th month. So first suppose it is January, February and March. At the end of March it will be charged, then April, May and June. At the end of June it will be charged, and similarly after 9 months, and then the last one is after 12 months, or we can say 12th month, okay, 9th month, at the end of 9 month, 6th month and 3rd month, right? So like this also we can write that it will be charged 4 times, because if we divide 3 months, right, if we divide see 12 into group of 3, we are left with group of 4 quarters. 4 quarters, each of 3 months. A year can be divided into 3 months, 3 months, 3 months, 3 months, that is total 12 months. So 4 years, that means for 3 months we will write, so n is equal to 4, so 4 times it will be charged. After the end of every 3 months it will be charged. First 3 months, then second 3 months, then next 3 months, and then the end at the end of the year. Clear? Let's go with the next question. It says, what amount is to be repaid on a loan of rupees 12,000? So what is the principal? It is rupees 12,000 for 1.5 years, right, at 10% per annum, compounded half yearly. As it is written half yearly, rate will become 10% upon 2, that is 5%, rate will become half. Time period, n is equal to how many half years do we have in 1.5 years? we have 3 half years, right? So let's calculate the amount. Principal into 1 plus rate upon 100 to the power n. Principal is 12,000 into 1 plus, what is rate now? 5. 5 upon 100 to the power n. N here will become 3. So we'll have 12,000 into, let's calculate, 5 1s are 5 2s are 10, 0. 1 plus 1 upon 20 to the power 3, and 12,000 into, when we take LCM as 20, 20 plus 1 will become 21 upon 20, and it is power 3, so 21 upon 20, 21 upon 20. Clear? Zeros will get cancelled up, all 3 zeros. Let's cancel with 2. 2 6 are 12, 2 3s are 6. Now you have to multiply 3 with 21 into 21 into 21, and we have to divide that by 2. So we get 3 into 21 into 21 into 21 divide by 2. So we are going to solve it, and we'll multiply 21 to 3, right, and then 21 and 21 and divide by 2. Let us solve it. So after solving it, we'll get rupees 13,891.50. This will be our answer. Clear? Let's move ahead with another questions now. Let us now practice 2 more questions. Just see here, they're asking in the first one, at the end of 2 years, on rupees 2400 at 5% per annum and compounded annually. Rate is also per annum and it is compounded annually only. So principal is rupees 2400, okay, and time will be, n will be equal to 2 years only because it is compounded annually. So 1 year and 1 year makes 2, and rate will remain same, 5%. So what will be the amount? Principal into 1 plus rate into to the power 2, that is the time. So 2400 into 5 1s are 5 2s are 10, 1 plus 1 upon 20 to the power 2, that becomes 2400 into 21 upon 20 to the power 2, because we will add these, 1 added with 1 upon 20. So you get 2400 into 21 upon 20 into 21 upon 20. Cancel the zeros. 2 1s are 2 2s are 4, 2 1s are 2 6 are 12. So 6 into 21 into 21 is 441. Let's multiply 6 with 441. 6 1s are 6, 6 4s are 24, carry is 2, 6 4s are 24 and 2 6. So rupees 2646. This is the amount to be paid if it is taken on 5% rate for 2 years, right? And 2400 was the initial amount. Clear? Now what is this, the difference in the first and the second question? In second question they are asking at the end of 1 year, okay, on rupees 1800 is just 1 year. So principal is given as rupees 1800. Rate is 8% per annum. Rate is given for complete year, and we have to compound it quarterly. It is to be compounded quarterly. How many quarters do we have in a year? We have 4 quarters, each of 3 months. 3 months, 3 months, 3 months, 3 months make 12 months. So n is 4 here because it is quarterly, 4 times it will be calculated, and rate will also become 1/4 of it. So rate is 8 upon 4. You know, half yearly when we do, so we divide it by 2. Now it is quarterly, we'll divide it by 4. So rate will become 2%. Amount is principal into 1 plus rate upon 100 to the power n, that is 4. So we get 1800 into, just to see, when you solve it, you get 102 upon 100 to the power 4. Clear? You can solve it and get the value for amount. You can cancel 102 and 100, right, like with 2, and then you can solve it out. So this is how you get the amount at the end of 1 year. Quarterly, whenever it is written, we are going to take n as 4 because there are 4 quarters, each of 3 months. Rate will also be calculated quarterly, so it is 8% per annum. For quarter it will be divided by 4, that is 2%. Clear? Here is a question, you have to find the compound interest when a sum of rupees 10,000 is invested for 1 year and 3 months, right? 1 year, 3 months, and at the rate of 8.5% per annum. Clear? It is per annum, compounded annually. So annually is there, rate is also given per annum, so rate will remain same. 8.5% is 8 2s are 16 and 1 17. 17 upon 2%. This is the rate, and principal is 10,000. So what will be the time taken? Time taken is 1 year 3 months, right? So time is 1 year 3 months. 1 year 3 months. So can you convert this 3 months into years? Yes, by dividing it by 12. So we get 1 whole 1 by 4 years. So let's put in the formula of amount. Okay, because we have to find out compound interest. For that we need the amount. So 10,000 into 1 plus rate is 17 upon 2, it will become 17 upon 200 to the power 1 whole 1 upon 4. Now how to solve this fractional power, that is major concern. So what we will do, for 1 year we will calculate it like this: 10,000 into 1 plus 17 upon 200, and for this 1/4 year we will use the simple interest. So we will use simple interest for 1/4, that is 10,000. Just see for at the end of 1 year what is the amount, because it is compounded annually, so we can't just take 10,000. We'll find it from here. 10,000 into, when you take the LCM, it will be 217 upon 200, cancelling the zeros and multiplying it, solving. 2 5s are 10, 0. 217 then multiplied with this, we get rupees 10,850. So this will become the principal for the next 1/4 year. So 10,850 into, what is the rate here? Just see, rate is 17 upon 2. So putting 17 upon 2 into time is 1/4. So 1/4. So we can write just 1 here and 4 here, and into 100 we have. So when we solve it, we are going to get the simple interest. So the simple interest come out to be rupees 230.56. okay, and this is the interest for the 1/4 year. Okay, and 10,850 you have to pay. 10,000 you already had, or you borrowed it. So what is the compound interest in this case? 10,850 minus 10,000, that is 850 only. So can we find out the total interest? Yes, definitely. We know for one complete year it is 850, and for another year it is another year, that means 1/4 of the year, 230.56. right? This will be the total interest that you have to pay, compound interest, if it is, you know, compounded annually and the time is 1 year 3 months. So we converted that into 1 whole 1 by 4 years by converting 3 months also into years. Clear? So let's us just add 850 and 230.56. so 0 0 we will take after decimal, 6 5, then we have 0, 5 and 3 8, 8 and 2 10, right? So the total interest paid is 1080.56 rupees. This is the compound interest that will be paid. Clear? Now here we are going to discuss some applications of compound interest formula where it is used in real life. So here only a few I have written. So there is increase and decrease in population. If we have to calculate, we can find it out. The growth of a bacteria, if the rate of growth is known. The value of an item if the price increases or decreases in the intermediate year. So for some years we have to calculate compounded annually those, right? That means after every year it is going to change. We use compound interest in them. Clear? So these are some of the basic applications of it. As soon as, you know, we practice a lot of statement sums, we will come to know its applications. And let us start some questions which are based on these applications. So here is one question. It is saying the population of a city was 20,000, right? In 1997 the population is 20,000. It increased at the rate of 5% per annum. Find the population at the end of the year 2000. So from 1997 to 2000, how many years do we have? 1998, 1999 and 2000. We have n equal to 3. And because it is per annum and it is annually it is increasing at the rate of 5% per annum, so we will use compound interest in this. How we are going to use it? Let's see that. So what we will do, we will consider the first, that is in the first year. What is the population? Population in first year. In the first year, the population will be 20,000. Okay, and that is in the year 1997. Let's consider this the first year. Then up to 2000 n will be equal to 3, and rate will remain same as 5%, because see, the population is changing at the end of every year. Okay, it increased at the rate of 5% per annum at after every year it changes, so it is increasing in compounded form. So we will use the formula for compound interest. So but now we will calculate population at the end of year 2000. So it will be, principal that we are considering here is 20,000, the initial amount 20,000 into 1 plus 5 upon 100, that is the rate, to the power 3. So we get 20,000, okay, into 5 ones are 5 twos are 10. 1 plus 1 upon 20 makes 21 upon 20 to the power 3. So we get 20,000 into 21 upon 20 into 21 upon 20 into 21 upon 20. You can cancel the zeros. Right, then 2 ones are 2 tens are 2 ones are 2 fives are. So you're going to multiply 5 into 21 into 21 into 21 divided by, these are cancelled, just we have 2. So we get the answer by dividing as 23,152.5, or if we estimate it, we can write it as 23,153. This is the estimated increase in the population. So at the end of the year 2000, this will be the population. The number of people from 20,000 will become 23,153. So we can use the estimation, like 0.5 was there, so we made it 23,153 instead of 152. Right. So see, we have used the amount formula for compound interest to find out the population at the end of year. So this is one of the practical application. This is the practical use of the formula that we are doing in a real life situation. So let us discuss one more question here. Okay, let us discuss one more question. It says a TV was bought at a price of rupees 21,000. So let us take the initial amount, that is 21,000. Okay, so price of TV, okay, that is rupees 21,000. After 1 year, the value of the TV was depreciated by 5%. You know, when we use the item and we want to, sell it again, suppose I have used something for one year, because of its use and its age that it has been used for, the amount gets deducted. I can't just sell it for 21,000, I have to decrease the price and sell it. So the price is depreciated by 5%, so rate is given as 5%, and that is deduction. Remember that. And we have to find the value of TV after 1 year. So you can use normally the simple concept. Reduction you can calculate. Reduction is how much? 5% of 21,000, and you can just write 5 upon 100 into 21,000. So 2 zeros will get cancelled. 5 0, 5 ones are 5, 5 twos are 10. So this is the amount that is decreased, right? That we have to decrease. So the value of TV, okay, after 1 year, you have to sell it for, suppose, rupees 21,000 minus the rupees 1050, and that gives us rupees 19,950. Clear? So this is just a simple way of calculating it. One more thing that I would like you to know here is, just to see, this is one method how to use compound interest in this daily life problem. So I'll use compound interest now. So I have the principal, suppose, as 21,000. I'll take it as principal because it's the amount initially. Now rate is 5% with me, but as it is deduction, always we have discussed the question of increase in, right, and time is 1 year. So if I use the formula of the amount, so we can say amount or value after 1 year, it will be 21,000 into 1 plus 5 upon 100 to the power 1. So 21 upon 1000, 21,000 into 5 ones are 5 twos are 10. We get 21 upon 20. So cancel these. Then 2 ones are 2, 2 fives are 10, 0. 1050. right? Just see, we are going to solve it, and you multiply 1050 with 21, you get 19,950. The same amount we are getting using compound interest formula. Okay, one thing, is it correct? So one thing that I would like to you to notice is it is decrease, and then also I used plus. So whenever it is a question of decrease, you will not get this answer. So now if we use compound interest in it, we will write 21,000 into 1. We will use, because it is depreciation, okay, it is depreciated minus sign upon 100 to the power 1, because see, we have the formula P into 1 plus R by 100 to the power N. So here we always used plus, because that was in case of increase, that was a case of increase. Here it is depreciation case, so we just have to use minus. So 21,000 into 100 minus 5 will become 95 upon 100, cancel it. You know, when you solve it, you get 19,950. That is the same amount as we were getting previously. Clear? So see, we have used the concept of compound interest here to calculate the amount or the value after 1 year. So this is a real life problem, right? And the compound interest is used here. Clear? Now we have one more question. You need to solve it. A machinery worth rupees 10,500 depreciated by 5%. So directly you can calculate 5% of 10,500, and then you can tell the value after 1 year. Or you can use value after 1 year will be equal to 10,500 into 1 plus 5 upon 100, that is the rate, to the power n, that is 1. But it is depreciated, so instead of plus, what should we use? We should use a minus sign here. So 10,500 into 100 minus 5 is 95 upon 100. So 100 and 100 got cancelled. We will get rupees 105 multiplied with 95. Let us multiply these to get the answer. So we will get rupees 9,975. This is the value after 1 year. So directly using the formula for amount in case of compound interest, we can find it. Clear? Now the next question. Okay, it is saying find the population of a city after 2 years, which is at present 12 lakh. If the rate of increase is 4%, rate is given 4%. Okay, initial value that is given, I'll name it as P. It is 12 lakh given, and time is given as 2 years. After 2 years we have to tell, and rate of increase is 4%. So how we are going to calculate it? Just see. So now after 2 years we have to tell. So we will write after 2 years population is, because it is increasing, we will use 12 lakh into 1 plus rate is 4%, 4 upon 100 to the power n, that is 2. So we are going to solve 12 lakh into 104 upon 100 into 104 upon 100. So we are going to solve it and we will calculate our answer. So by multiplying all these things, we will get the answer as, solving it, we will get 12,97,920. This will be the population after 2 years if the increase is 4%. Clear?